Alright, so CSC202
Let's-
midterm
we
review
gotta
again
go to
for
app,
recursion. So we're
source,
going to
right.
talk about the slide
and
Okay.
main.
again
this is where
from
our Java
Neil
is
Dill,
main
Daniel
activity,
Joyce, and Chip Weems.
Okay.
Okay.
And then next is we're gonna go to look
Right,
for
so recursions.
The spinner right
What's
here, right?
recursions? A smaller version
so we
of
create spinner.
diagonal line. So if I want you to draw
the smaller
Let's
versions
review one more time,
of
right? So main activity
values
is like
that
your
you
main
pass in,
extend app
right?
compact
if
activity.
you talk about the method
So this is pretty much an Android application
of itself,
right?
yeah, smaller version of itself.
And
Like
then we have it on create.
this is the
And then
Persian doll. You know that
This
when
is
you
like
open it, you
start
see the
with
smaller
Japanese,
version
right?
of the lady. Right.
Now we pass.
You may have
in
seen that, right?
the create instant
The
name
Persian
save
doll, right?
instance state, right? So it's going to create
Correct.
that here. So it's
So-
pretty much just follow this format all the time when you use Android, right?
In the term
Like
of
this, you can see all the time right there. Just like JavaFX structure.
programming, a good example
Now,
is the
next
when you
step
want to
that
repeat
is
to do something over and over again. We
set
can use a
content
loop,
view.
or you can use the recursion
That's pretty much
as
just
an
linking to
alternative, right?
the layout.
So let's say, for
which
example, if I
is
want to write
created
program for
right
to
under
find factorials,
RES.
so
layout.
so
you could do iterations and you can do recursions to do that.
actually
And
So
we're
let's
looking
see
at
if we
activity
call
name. So this pretty much is
factorial.
linking to the UI. So that lab code.
I'm going to
same thing
create.
that's created
So
so
we can use
Okay, so where
the
you can
loops
drag and
first.
drop, right? How do we get
So
spinner?
how we
This
gonna
is a
do
spinner.
iteration with loop?
Correct. Now we're gonna drop one more spinner.
so that's gonna be
And last time we have to work on the layout too, right? So let me try to use different layout. I'm gonna use linear
Okay, she said
layout.
for int x
I'm gonna move everything
x
to linear
less
layout.
than. I just try to copy the statement, right? So keep saying.
So is it, and it's like less than like the factorial, like the variable you use to find the factorial dot lane semicolon x plus plus. We have
This
to
is a
find the
spinner.
variable, but that's
single line comment.
Dot n. Okay, x plus plus. Okay, that what you try to say.
no, I was trying to say like n dot length because like your
N dot length.
like the size of like the number.
Okay, what's n?
I think n is like
We have to declare n.
so int n equals 10. Let's just say.
Now the problem with this program is everything is x and n.
If you want
I
to
don't
like
understand
this,
what you mean n, what you mean x.
Okay,
It has to be
I'm gonna
x,
share
has to be
that
n,
out.
it
Okay,
has to be
I'm gonna
y
use
and
the
w and
constraint
c and
layout
d.
now. Do I have to
And then the
mark
answer
down
is
here
B.
first? Let's see table
That
row.
is a bad way to name your variables in Java program or in any program, right? So good practice in naming is give the whole word to it.
Alright, we gotta learn how to use the layout. Okay. Now let's focus on spinner first.
going to have
Okay,
So I'm going to
what is
put
n?
another spinner.
N is the factorial number, you mean?
So go back to
The variable then. So
widgets.
if one of them is
This is a spinner.
smaller, like
Okay, number.
Alright, so just add another spinner.
And you said yeah, it's equals 1 and x less than a number. You increment a number. Now, how you going to multiply it? Factorial is it adding or multiplying?
so if it's
Alright, so let
Okay.
me put a grid layout and put a new spinner on the grid layout. Now, let's look at the spinner.
so I'm going to draw like
Okay, who's gonna say? You said increase by
So
1.
this is the name of the
So
spinner.
increase by
right,
1
ID
is, you
spinner.
mean which one increased by
So
1
what I'm
number or
gonna do, we
x?
gotta put we gotta do the month, right? So I'm gonna say month spinner, list of the months, right?
outside of the folder, and then inside type factorial.
So I just try to give the ID to. Let's do one more time. I don't see it change.
But then we need everything else. Like if
We want to use the loop, right, to do the work. We didn't want to use recursive yet, right? We talked about using loops to find factorial.
Alright, so now what we gotta do, let's review the
Okay,
layout first.
factorial, right? Okay. Equals to. Yes, slice 2.
We want to make sure we
One.
see it. Okay.
Factorial will equal factorial time number.
So if
We
you want to
move
make
it out
this,
first.
Okay.
Then we're going to put this back. So it looks like that is a spinner right there. Okay.
nice, 2 hours, and then
Now we come back to
it
decode
we have
main activity here. So we need to get the spinner, right?
so
So this is the previous spinner. Let me rename it to rows spinner, right? Because we have 2 different spinner now, right?
And this one should be.
like you put a black
Now we start to have the second spinner that we just add. I call it month spinner.
just need to think about location.
So pretty much we gonna put the list of the month, right?
That makes it so in some number at this point.
Find view by ID.
And if it is a circle, I'm sure it's going to be the same.
Okay, it's not seeing it. Let's double check if.
So what's the factorial of? Let's create a method.
So ID, yes, month spinner.
How we gonna make this as a method?
Right, so if it's a 50,
Do like
50
public
is about this one.
static. It could return a value. You can have return. It could be like
Okay, return.
return a value if you want, or it could just be like void depending on what you want. But and then like in a main you can ask for like a number, so you have.
So
to
we
pass
have
a
it
number.
under activity main.
This is your X.
Number. Okay.
We have row spinner here.
And that's 5, 7.
Okay. Returns
Month spinner here.
factorial. All right, we gonna test that.
But we can say
We can actually test with.
So let's find out
The
what
unit
happens.
test,
We're
right?
not seeing it.
So we got 1 X. Alright, so to complete the happy face,
Hmm.
you need another X.
Dot ID dot. So we see all the IDs here, right?
In there, like, create a file called test.
Copy this line.
So let me change the name again then.
It's like for the you clicking on dependencies, you have to click on sources. It's in there. You create a file called test and mark it as test, and then go on your method and right click on create test for it, and then you just highlight
Spinner.
the method.
So let's see what he tried to do. So you say create a file called test. You mean here? You mean this one? Okay. And then what?
Do
Hit
this.
OK.
I'm gonna comment this code.
No, it's not doing it.
Refresh.
Okay.
Whether
Not
it,
bad.
let's create IML file for me.
Go to door.
So let's
So
Let me
delete
try
it.
to run this first.
A half oval. We may have to use door arc. So it's gonna be same location you want to.
So there's an error
Seems like it's
here.
all gone. What happens now?
Doesn't exist or has.
I
to
just
correctly
delete
tag.
the
So
whole
it's looking
project.
for Android manifest.
90 degrees, 180 degrees.
Okay.
So let's see how to use this. So for example, if I say I want to start a location,
It still have the IML, I'm not sure, but Okay, we leave
So
it
this
with
is the
that.
Android manifest that I was looking for.
Highlight
Just saying like it's about mobile. So it should be smaller than this.
Let me try to
Yeah, for
switch
mine
to
doesn't
another
show.
app to test what happens.
And
But we can go here.
because I want it to be
They have the
horizontally.
I think should be code.
Start angle. So you may look at. I want to start.
I think it's
at-
under analyze, right?
This is like a unit circle. 0, 90,
Okay.
180. And from 180, I want to
Alright,
draw
so now
away.
this is just need to test on the phone, right? So like I also have the emulator also right there.
It's just the name of my project.
So the
That's
emulator
why.
require me to install the HAXM, which
Start
if you
from
install that,
180,
it should work.
If I stop at 2
But now I don't have the admin right to install on this machine, so I'm going to test on the connected device.
then I want to make it.
Now let's say my device kind of
It's gonna stop right
very old. When you're dealing with old device, you might not be able to. You may need to install driver. And
right here where starting point and draw for another 180. It's going to draw up. Stop right there. So
I think he showed me last time.
So what I'm gonna
Jonathan,
do-
you go to analyze. That I see.
Actually, maybe I need to borrow one of your devices.
When you're not on this machine last time, him, Jonathan, right?
Because my device is not showing.
To go to
here.
the unit
I don't want to
test, you
spend
can
time
add form.
to debugging it. It's the LG
Navigate. There you
screen.
go. Navigate.
Like I was setting up on my personal laptop.
Yeah.
It's take a while. I have to install driver. and-
Navigate. When you don't see,
Yeah.
you go to navigate. Huh?
Control shift.
let's say 100. Right. Left.
Yeah, it's because you didn't define like the number in the.
Hmm.
Is it because you added that module?
Okay, it's about location that you have to manage.
Interesting, huh?
Right. So if you
Alright, so we plug in another device now.
we got
Okay,
it in mind.
it's show up now, right?
Alright, thank you for watching and again,
Alright, we gotta test on that first.
email me if you have questions.
That's how I do it for every time.
So this is just
How do you add
another
another source?
application that I
Also,
make it
so I
simple
want you
with a
to
button,
practice.
and once I click the button, right,
No.
it's going to
Start
Unclick it. Okay.
looking at
it's gonna call toast.
to draw.
Okay.
So if you remember, this is like in
I want you to make
JavaFX, right?
okay.
We do.
So you know how to
If you remember that we do like lambda symbol, right?
tic-tac-toe.
So this is like lambda here, right?
Just make it tic-tac-toe
Correct. We do E and then we do lambda.
table.
So you just set on click
Why is this doing
and do
this?
whatever you want. Like it could be
Which
system.out and print hello,
You can
right?
have
Missing
OX
And toast pretty much just like a pop-up dialog on the
You're
Android,
gonna
right?
do
At the
it
bottom.
with tic-tac-toe.
So I just
What
do
package?
toast and make the text to show,
and
right? Show, and this is a text. So it's just like JOption pane dot show message dialog, right? And this is just
Okay.
toast dot make text. Make
if you
sense?
like,
And this
you
is
can
like
also make
where,
a
like in JOption
either
pane, it's just
vertical
null,
line
right?
or
This is just on the
horizontal
application context, right?
line.
Get application context, and then the message,
This one?
So
and then you can just set the length,
And now if you go
right? And then do dot show.
test it.
Okay,
Oh,
makes sense.
cross.
All right, so let's test that.
I'll let you decide.
We're gonna run on this device.
Vertically, horizontally, or diagonally. And enjoy drawing.
Lambda actually represent this whole thing when I hover it.
1 second.
Okay, now,
when I go
This
there.
represent that you create a new view,
Navigate.
right, on click listener and create a method on click.
Welcome back.
Isn't
Create
this
new
source and
test.
Okay, which if I
There you go.
expand this, it's going to show this is the whole thing represented by lambda. Now I'm going to explain that. Okay, but let's take a look at
And what is the good
app
practice
first.
for?
I'm going to switch to docam, then you can see.
We can go back and take a look at our old.
All right. So we gotta test that, right? Call.
So once I hit a button,
Look at this.
I get a text, right?
There's a warning here.
According to the code, just click and
Scroll up
toast
the mouse.
message.
I'll move to cursor.
Okay.
System
We switch back.
dot out.
Right, just like the
Print
message that we see here. Very simple, correct?
Factorial.
Now,
It's very important that
So what's
let's
factorial
explain this
of
part a little
4?
bit further.
when you cross,
So
24, right?
if you want, you can review on your course document folder.
so for example,
This is an
an instance named
it's just like in JavaFX, okay?
and we start to use it right here to read in
Okay.
I need
so
to
it's the
get
same
to
concept.
create an object first, right?
For event handler, robotic call, like the option pane. I mean the swing.
Let's make it
part of
static.
Java or JavaFX,
There's no
they call
reason to
event
have.
handler. So
Because factorial also is the
we
same,
start
right?
to understand
To have it as an object.
we create class, right, every time. Right, we
Now,
create
the
class.
reason that we want to cross is
Now, what we want to
Okay.
show you is what is class? Class represent the new object, right?
Package
So,
doesn't exist.
I want you to look at the event handler here.
What
that-
would have we
we don't want to leave it
here, right here.
did?
because they can cross a resource free.
Yeah, this is the, under the course document that
We
like
have
I said,
factorial
I want to explain
project.
that part. Then you
And we
understand
have
what.
test,
Programming like C.
So, in this
And we
section, it's
have
talking about
you
package.
normally need to close whenever you open the connection
Oh, I see.
program. And
Hmm.
Assignment,
pause.
it was supposed to be
In this
submitted.
case, our system.
What would have we create before it's missing?
So when we finish
Org.junit doesn't exist.
Combined together, right?
yeah.
into our program,
But there are two different codes, right?
So that means the library is not existing?
otherwise we still leave it open. That
All right,
means
let's come back to
all
this.
the
So,
still open.
like for example, you click button.
Pretty much just
It depends on action event.
there's going to be a lot of data coming in.
So this is like event listener. Like this is going to demonstrate the image, like the button. Where you click,
That means it's
alright, when you click, there's an event, which is
It
an
just
object.
couldn't find the
And then the event handler
package,
process the
huh?
event.
slowing down because
Like unit test.
Like the button,
so we
you do set on action,
in Java we may not see that
Right.
problem
and then we have handler.
because Java has the JRE, which is going to take care of that.
We have handler. So the handler
Let me
pretty
try
much
create one
just
more time.
an object of the
Use
class.
unit 4.
So the next good practice,
Do this
We
one.
create new class, implements the handler,
normally we like to
Okay.
and
when you say
So
the
when
handle
we
is
run,
the method.
so
This is handle class, and this
so
is
is this the
handle
path issue now? We couldn't find.
And then we can say
How
whatever the
come?
button
Because
click,
the way
it's
we
gonna
create
say
here, huh?
the message, or do whatever the handle,
The structure that we
right?
create.
While implementing the handle method.
before you using it.
Okay, let's look at one more
Let
time here.
me try replicate the project.
Scanning
So we have the button. Once you click the button, it's fire an action event.
and
So event pretty much is an object. Okay, that's going to have the event handler to process the event.
also string
Alright, so let's look at the button again. When you click reset on action, that
Okay.
create the event object called
Now I just
handler
created.
one.
So let's try
And this
again.
handler one is the event
go to
object of
this,
OK handler class
navigate.
that we create right here.
that was your
Create new
Right,
test.
once
This
you
should work
click,
this time.
instance name or the
It's going
So
to
unit 4.
create OK handler class.
It's missing
then set
the
on action
package,
call hello
so
one.
we add right?
to class path.
And then the other one has a handler,
I see you use first option.
right? To have the method handle.
Let's
so
run.
implement event handler. So it's always like that. That's a pattern.
Okay, it's good
Right?
this
That's
time. Right?
actually replacing your lambda.
So
since
now
have
we
different
could
question about
just
what's
use
lambda,
this.
Right? So this whole thing is the lambda. Create the object. This whole thing again.
So it's about a class path
Create event
issue.
object. And has method to create
Now we run.
handler. Like handler is
Okay,
pretty much just
so
being
now one
implemented
value works,
and
right?
has a method to handle it. So this whole thing is
Does it
lambda.
work?
So that's why lambda just
When
make
one
it
value
so
works.
simple.
0 doesn't work, right?
Okay, you see this in 201 again. Okay, that we emphasizing. So that's why this
Because
point,
when you
at this
pass
point,
0 in,
you just need to
it's supposed to give you
understand that
1.
we actually corrupting the whole thing that we seen before into the process we call inner class first. Inner class, just like the nested if inside if,
X
it is the
less than
class
equal to
inside
0.
class. Right. So meaning that if you look at an example of inner class right here,
So 1 less
So
than
we
equal to
create
0 if
a
you never do
program
loop,
with a
right?
button, we
They
set
should
on
return 1,
action,
right?
We create a class. So this is a new class, right? This is a class
You
which
run
is
it. It
the
should returns 1.
event object. When you
Oh,
click,
sorry.
event object say enlarge handler,
That's the old one
and then
having
we
issue.
have event handler to handle it by enlarging
Right.
the circle.
So that works.
So this program pretty much
So,
you click and it's going
technically-
to enlarge the size of the image of circle.
One thing that we have
So
think
now
everything
we
is
said
working
this
then?
whole thing, like I said, the whole thing is I try to explain what's lambda, right?
Factorial with double
Put it
values?
smaller in the term of
Do we have factorial for
anonymous
double? You
inner
mean
class.
double?
This is called inner class.
Instead of
Before, it's
integers?
just two separate classes.
You said not
we
integer, right?
collapse into inner class, put in the same class.
And why you want to use
And then
double?
we said we can collapse them even further into anonymous inner class. Why? Because
Oh,
when we create
okay.
a new object, we
It's not
always
going
do
to
the
take
same
double
thing.
because it's
Then
in,
we can
right?
actually technically replace this blue highlighted with the
How
whole
do we
class
know-
here inside that parenthesis, right? This blue.
How do we
So we
create the
just put the whole
recursion?
class and put in there, as you can see, right? Our implementation just inside the parenthesis of the method set on action right there, highlighted. Now we said in that case we can just eliminating the word class enlarge every time when you do new.
Okay, the number.
Do new,
Okay.
right? Event handler, right there. But what will we handle is right there. But we have the whole lambda replace this whole thing.
I want to show you
The highlighted
You say
part
if,
we
okay.
use lambda.
If
scanner
We just do e.
number.
That makes sense.
So we try to find
That's
best case,
why-
right?
This whole
You
part,
said if number
we switch
equals
back,
to.
This is what we call anonymous inner class, right?
Is it what's the
That I just showed you.
best
Do
case
new
is
is
what?
just
Best.
collapse the whole class into that highlighted part,
0 or 1?
and we collapse again into just lambda.
new class.
Now
Because
the question that I
user can pass
have
in
is,
zero,
what is
right?
lambda?
If number
How we
equals to
ask, so-
0.
Like I said, if I explain, it's just a little bit
Okay, what do we do?
more advanced at your level because this is going to come
What is
into a
the
1.
limiters? The limiters
But like I
is
want you to know that this is called anonymous inner class
We
at
always
this point.
returns factorial, right?
So lambda just make it so simple,
type the name.
right? It's
Why
replacing
return
that
0?
whole code. You may see that.
Then it's gonna read it.
Factorial 0 of is 1, right?
And V just represent the view
Limit that
right there.
to stop
Else,
Right, we see E last time. E
That
just
mean
represent the event.
if it's not equal to
Like
0,
action
then
event.
because
Yeah.
it's going to return 1 for me already.
which is
Like this one is going to show you further.
What's the
into
best
lambda.
case? Yeah, let's stay with
Right
this
there.
idea
See that?
first.
It
Best
say,
case,
okay,
we
anonymous
said
inner class right here.
it's going to return
We can
factorial.
actually replace with E. See this whole thing just replaced
can
with
also
E.
change the
Okay,
default
let me just say, how do we say
Right.
returns factorial here?
to
And we call lambda expression event handler.
so for
Else
example,
pretty much
Okay,
I'm
just
going
like
when it's not
that.
equal to 0.
Anonymous
So are you
inner
looking for
class.
else if
we replace with,
which
number
is going to have
equals
lambda.
to 1?
standards.
all right? And
Pretty
then
much just
whatever,
return
when I click the
factorial again,
button,
right?
it's just do whatever I want it to do, like
And
say hello world.
Else
Exactly.
It just makes
Okay,
it
let's make it simple for now. I'm going to just put
Well,
like
like I
that.
said, at this
right?
point, just
Else,
use it.
else now
And
else
then
that means
when you
this
get
is not,
further,
no
then you
longer
see
the
that.
best cases. These are two best cases, right? So what would it do?
For instance,
This is replaced with that, right?
when you declare
So wait, it's like the a nodal format.
All right. So now
Like
in the Android, we probably has to type the anonymous in the class.
not like a
Okay.
variable.
But when you collab, it's only show the lambda symbols. We're not using while
Okay, not
because
like
it's
that.
recursion.
You can just type the
No loop.
lambda right away.
Yes, you call
This
itself.
one we
you
don't
call,
need it. I just try
call
to
itself.
test, yeah, like when I run.
And you pass a
just try to see
smaller
it should
version of
print
itself,
on the
right?
console too, right?
Yeah.
So now for
Yeah, for the console.
But you have to say factorial times.
using the method
Okay, another
You put down there was a limit to 3.
we can let it
If we raise the limit with that thing,
ending with
so if we set the limit to 5, because like some websites, you know. have
So what
limit
is
like
the 10
some
factorial?
boundaries, would that be okay?
If you write in math, right? 10
Alright,
factorial
so we
equivalents to
connected
what?
to device, and
1 times what? 9 fact, right? Which is exactly like that, right?
so now
Like factorial equivalents to
with the system now
factorial times 1
Alright,
times 9
so
factorial,
we-
right? Because number minus 1 is 9, right? And then you get a new factorial, right? And then
now we're going to
the 9 factorial is, let's do just 3 factorials. What's the factorial of 3? You pass in 3. So it's going to be 2 facts, right? So it's going to be what?
so
It
I
is a
switch to
three
it. You see this Android
So
monitor?
the first
Whenever I click, it's going
the
to show
first
that
recursive
from
is
system
gonna
out
call
line here, right?
like that, right?
See that?
That's the first recursive, right?
It's system
And the
out.
second recursive
You
is
click
pretty much
again.
just it's not
just
going
try
to
to
do
test
anything,
that
but
Android
it's
is
going to do,
So it's going to keep printing.
since we call 2 fact, it's
Let
called
me
itself.
actually try to see if
2
I can
passing
clear.
here, which is going to do else again.
Now I'm going to click. See
Right.
that? Whenever I click, it's
Else
show.
again now.
I'm going to click the second time. See that? Show again.
It's going to be what?
Make sense?
and I said by
So just to show
Actually,
you that
it's supposed to be 3 times 2 times 1, right?
using dollar signs
So actually this is wrong, right?
on
All right, now come back
Correct?
to
It has to be 3 times 2 facts, right?
spinner, right?
Alright, so let's see if I can use this one then to add a spinner again, because the other one
So
looks
this
like
should be
it's
numbers
wrong.
times instead, right? So again,
Because it's gonna
this
be
one is R
instead of fact.
ID, right?
Right.
Activity main, the same thing. So we go to
explanation of this
So 3
source,
times 2 fact, right?
main,
And
res,
that's
right?
third
Layout,
time is
right?
gonna be, the second time is gonna be 2
Okay,
times.
so that's pretty much
because
what we
number is
have here.
2 and then 1 fact, right? And then it's going to be 1 returns 1
Yes.
back. So that should work, right?
So first thing, I guess, let's try to
So
play
let's
around with
test
the
it.
layout first. Okay.
So now we can use unit test to help. The reason why I want to use unit test, then we can do assert, because we see the loop is already
So by default,
correct,
use the
right?
constraint layout, which
So the first one is expected, right? Okay, what's the expected? Let's say, right?
so let's see how
We use 4,
the
right?
will
Expected
being
24, right?
So first, what is constraint layout, right? Let's look at what's constraint layout in.
Yeah, we gotta do that. But we don't want to skip this step. We don't even know if this one works yet. And this is 4, right? We want to make sure 1 works and then we do the loop. So it looks like it works. Pass the test, right? Now we can start to use the loop, right?
So it allows you
So
to position and
we
size
just start
widget
from
in a
0.
flexible way.
Right? Less than. Let's go to slow down machine.
And these
Let's
are
use
the
30.
type of constraints.
It's very
that you
slow
can
already.
use.
Remember we talked about efficiency already, right? It's exponential time, right?
So let's look at the first one, right?
So now
The
expected
relative
is going to be
positioning.
what?
Now
I.
Isn't it like it does it like
we're gonna test
lower
it.
time, but it's
So it's the basic building block of creating layout
Both.
in constraint layout.
Both. It's going to do both.
So those constraint allow
Alright,
you
so
to
it's-
position
you see
a
that's
given
the
widget
good thing about using
relative to
recursive.
another one.
I mean using unit
You can
tests
constrain a
So
widget
expected
on the
17,
horizontal and vertical
but get
axis.
this.
Horizontal axis left, right. start,
Okay, so
and
17,
ends,
why is
sides.
expected 17? What factor give you 17?
And vertical axis is top, bottom, sides, and text-based line. So the general concept is to constrain a given size of a widget to another size of any other widget. Like for example, in order to position button
Oh, so
A
then we know
to the
17
right
is the
of
problem.
button,
Because
like position
maybe
button B to
17
the right
is
of
too
button
big
A.
or what? For it to handle.
So this is relative positioning
So let's
example.
do system that
So
out.
what we're gonna do
and see the
on the
values, huh?
Android, we have to say
We could do
layout
inside
constraint
too,
left
right?
to
Let me
right
see it.
off.
So
Okay,
let's
let's
say
see. We're gonna test that.
factorial, and then we pass
So
in
let's
the
say
I,
we go
correct?
put the button. Okay.
And then we say
So again,
equals
this is an
to.
XML, right, file that we can always see.
So we want to test this, so we're
This is
gonna
an
use
XML
this
file,
guy.
right?
So can you
Remain
find the
XML.
factorial 17 for me first?
So if you look at, we can
we
switch to
find factorial
text,
17?
right?
Maybe
So we have hello world,
Google it.
we have button.
I want you
So
to
this
Google
is the
that
button,
and let
this
me
is the hello
see.
world, right?
Right? That's why it's
So
caused the issue,
If
right?
you look at hello world, it's being set as
It's-
constant bottom,
Give you an issue already.
Right.
Let's see 17.
constant left, right, top
That's one, right?
to the parent.
But that's
So that's
the problem,
why
right?
you
Can
see
integer
it
handle this?
is all centered, right?
That's why,
because
right?
it's to the parent, right?
Because we have it as
Parent
in,
is
unless we
the
do
gray
long.
area right there. Now you switch the button.
Which-
button never do the constraint layout
Maybe
yet.
change them to
Right.
long, right?
It's just do layout editor absolute X, right?
Hmm.
So now, what we're gonna do, we could just use this too. So let's say if we do
Right. So that's fine, but we know the why is right. That's
the
cost,
same
so
thing,
we can make
okay.
it 10.
We put
It's that pass the test. So it looks
This is
like
an
both of them are
ID,
working,
right?
right? Correct.
now it's centered the same place.
All
See
right.
that? Overlapping.
So
the
that's
whole world,
recursion.
right?
That makes sense.
But now,
so
if
now
I
let's
want
let's
this
summarize
to,
the idea first.
like switch back.
So how do you make
let's see if
recursion?
I want to go to the bottom of the text, right?
Now, if you look
So
at
we
this
could
image, this is
put
showing you
the-
the efficiency, right?
Hello world has. So we probably want to.
So
let's
we
say
say
hello world
if
go
n
the
equal to
top.
0, then
right,
we
of the
say
button.
1, right?
So we could
Technically,
refer to
the
this
one
constraint,
case
right?
we don't really need if n equals
This
to
is the button
1
constraint
because one fact
to
is
the
going to
top
returns 1.
off, right?
So technically, you could eliminate
Okay,
this
if it's to
because
the
it's going to
top,
fall
that
into L,
means
and then L is
top
going to
of
take
hello
1,
world, right?
and 1 times
Because we do
1
add
is
hello
going to be
world,
1
right?
back,
It's the button. See that?
or whatever numbers times.
So
right, 1
if
times 1.
I
Makes sense. So that's
go
why
to the
it's
bottom.
eliminating that case.
so it's gonna go to the top.
It's
of the button,
still
right, which is the bottom
it's still
of the hello
able
world
to
is gonna be the
test
button.
and pass it.
That makes sense.
So that's a good thing about
So
unit
that's how you
tests. You
do
see that,
layout, right?
Once you change a little bit, you don't have to rewrite the code. Right?
So we gonna move. Same thing with text wheel. We can
Now-
do constraint too, right?
what we did, right? The numbers times the small version of itself, right?
This is just another
So
type of.
we can see when we
constraint
call
setup.
full
We're not gonna use
factorial,
that yet, right?
it's actually do the
4 times 3 fact. Like I said, it's called itself. It still have that in the memory. And it's going to do the same for 3 facts, 2 facts, 1 fact, and 0 fact. So you see, it's going to occupy a lot of memory. So let's say we gonna make until it returns 1, then returns back to to 1 go fact, to the bottom, and then 2 fact, 3 fact, and 4, and get the button. So that means the top of it has to be. So the algorithm of recursive is just smaller, right? So let me small instance of itself, the idea of the button, and has the best case. So that's it. Like when you write a program, you have to focus on. So that's how we do layout, correct? Making recursive. Now what we're gonna do? We're gonna do a spinner now. Best case pretty much is the case that will terminate. We're gonna add a spinner, and we're gonna do layout and smaller version of itself right there, right? It's called itself, but passing a smaller version. And we're gonna add spinner. That makes sense. So this is called a recursive. So what we're gonna do? We're gonna do a layout of the spinner too. Right? So again, we're gonna use the. So we have seen that we created a factorial already. Constraint. It's the same code here. And this is just explained again. So we want a spinner and returns. So let's make the spinner go. So we have the terminology recursive call. So which one is recursive call? Like after the text view then. This guy, right? Like at the bottom of the text view. Right. So meaning that direct recursion in which a method directly calls itself. You can actually use XML. So this is called direct recursion, right? Okay, so like now this is a spinner here, right? So let's check. Indirect recursion. So now we see the direct recursion. So indirect recursion is recursion in which a chain of 2 or more method calls returns to the method. So first I'm gonna make it that originated the chain. For example, method A calls method B, which in turn calls method A. And then so that's like indirectly call. Underneath text view, right? Right around there, right? We have seen the recursive. That means text view. No, this is the iterative way that we did. Bottom, right? So I need to get the text view ID here, and then to the bottom of the spinner is the text view, right? So now it's just talk about how do you construct the recursive. There are 3 questions. Like, should you use recursive or not, right? Like, or when you want to develop the recursive, right? You want to ask 3 questions. Text view. First, and if there's a best case to it, the spinner has to be the button. Second, it is smaller caller. And right, that is recursive call to the algorithms involve a smaller case of the original problem. That makes sense. Alright, so we done. Third, how to if there's a general case. Now we're going to go back to the code again to make sure we can refer to. Assuming the recursive call to the smaller case works correctly, does the algorithm work correctly for the general case? So now we're going to create spinner, right? So we see the best case is that n is 0, right? Smaller caller question is parameters n is going to be n minus 1 every time, right? General case is going to assume that recursive call give us the correct value of n minus 1 factorial. And return statement computes in fact n minus 1 fact. Okay, now we have the spinner. We gotta learn enum, remember? So we prepare. Now, when you first time writing recursive, it's gonna be a little bit challenge. Like, what's the best case? So we're gonna create a class. So this is just try to list out step, like get an exact definition of the problem, determine the size of the problem, identify the best case, and identify and solve the general cases. That's pretty much just what you have to go through. Let's try this first. If I do, you can use the light program for Tower of Hanoi. Can be a recursive. right? As a
Okay.
type, right?
to do
The data type. is
Like
one.
this one is a little bit
then I can
tricky.
start to do
Like
the
you
values.
call itself. See that?
January.
Do towers.
February,
As long as you still have the number of rings in,
April,
and you pass in the start picks,
June,
end pick, and aux
July,
pick, and but you're switching around
August,
every time. Because if you remember, we talked about that. Just go to the
October,
2, 4, and then back to 2, and switching around.
December.
So that's why this is just keep recursively
So-
it's by itself
I just create a new type
and make the
name,
program so
month,
easy to read.
and
And
the
this
values
pretty
for
much
the type are
very
consists of
small
the month,
Tower of
right, January
Hanoi.
to December.
But if you don't use recursive, how we gonna do
Alright,
this?
so we gonna set
Right,
the
to get
spinner
a-
to have
the
this values,
minimum
right?
move, right?
Alright, so we know that
And this is
with
another
that, we
example,
could
like counting
use-
blobs. Counting blob is just you're going to find the adjacents, right? And you group them as a box. Right.
put enum here.
So
you
can
we
use
could
loops to
use
do
my spinner.set adapter new array
as
adapter.
telling percentage of like the
Okay.
X.
So let's try that. So our spinner call
And this
spinner,
application
right?
pretty much just can use in the image processing
dot
to
set
see,
adapter,
right? And the image has the pixels.
right, and new
And see how many
array
like
adapter.
color
And the
with
type
that, and
now
then you
is
can
going to
tell
be month,
right
having
away
split,
that
right.
is this the water,
See that?
this is the mountain, and so on, right?
All right,
Or
so
wood area. So,
now
but
we
this
can
is just
do
algorithms
this
to do counting
and
block.
.r.layout. Pretty much just
Then
linking to the spinner, right?
just try to. This is just using the loops, right?
So this actually refer to this class main activity. Okay, where we say this.
Now this is try to change it to.
We're going to
We don't have the code in here.
call the
You can look in the
Android,
book.
right, for R,
So
right, to link to the spinner.
It's just pretty much just mark it as visited. Then you just do call. This is using recursive. So you look in your textbook, they should have the code. Let me check.
So it seems like this is going to link to main, our main activity, right?
You should have access to the source code too. I provide on the course documents, book files right there.
So this one, they link to simple spinner item, right? Simple spinner
Type of
item.
Hanoids.
That's what we want. So
Great.
it's just like the one that we use, but this is referred to spinner, right? That we want to set to the item. We just refer to layout and refer to the spinner item right there. And we can get the value, right?
I'm gonna use this application.
So the value just for my enum. So
Yeah, this is a
like
counting
I create
blobs,
the
right?
month dot
Block
values.
count.
So it should populate the value into my spinner. Okay, months dot values just give all the values here.
So this is the recursive one, right? Mark blob, call itself, and keep marking, call itself,
So
and
let's
keep
try that.
marking.
To see if we get the values first.
And we want to show you how to output
Looks like they use both the
instead of
loops, and mark blob is the
Again, here we know
the
it's
place
the
where they
values
use
because
recursive.
this is at the design, right?
graphic.
But the code when we run, we put the value at runtime, right? On create, we
But
get
this is
the
going to be
values.
steps.
Okay, so I mean, I don't want to spend time on reading this code, but just showing you a little bit of recursive application here. But they use recursive and iterative together to get this done. Okay, you can spend time on that to look into details. And that's pretty much, I think, it for recursive. The rest is pretty much we talked about that already, linked list. Okay, so we have reviewed that. So
Okay.
now
All right. So let's take a look. So it's being
let's look at
loaded
this
to
one.
the phone.
But we gotta look at more expressions.
This is just talk about the storage in
So we have
recursive, right?
January,
Plus, we can also
and then you can select, right? All the data.
So let's say
right?
operation.
Okay. And this is the layout that we created too, right?
We would say add.
Correct. So let's look at linked list again.
Alright, so now
Okay.
we get a value. What we
So
want to do next is we can toss to
the program
the
asks you
application.
like this.
say when you select values between, let's look at the application question.
Let's see what they
So
talk
go
about.
back to your class
It said
exercises.
supports the recursive call in the last action executed in a recursive method. The recursive call causes an activation record to be put. So this is stack, right? So we're talking about stack. So application. So this is stack,
When
right?
I select the month between December to February.
It's the
so
last
we want
in,
to
first
do
out.
something, right?
That's a stack.
Call.
You can use stack
Watch to
in
make
like
happy spring break
runtime or
days,
system stack, a system data structure that keeps track of activation
so
records during the execution of a program.
Let me start to
Each nested level of
Yeah.
method
How do we do
invocation
that,
adds
right?
another
So we get the
activation
values
record
from
to
this
stack.
code. Let's redo
As
one
each
more time.
method completes its
We use
execution,
set adapter
its activation
to create
record is
array
popped from the stack,
to
like you
put
done, right?
into the spinner
Recursive
array
method calls
adapter.
like calls to any
So
other
pretty much
method
just
cause a new
array
activation
pretty much
record to
is
be
group of
generated.
data. That
So
is
depth of
gonna be
recursion,
month
the number of
type
activation records
that
on
we
the system
put
stack
into the
associated with
item,
it given
right spinner item of
a
the
recursive method,
Android
right?
layout. By these are the
So,
values that we put too.
Okay.
supports the recursive call is the last
Okay.
action executed in a recursive method.
Now
Project.
The recursive call causes an activation record to be put on the runtime stack to contain the invoked method's argument and local variables.
Before you reach a certain
When this recursive call finishes executing, the runtime stack is popped and the previous values of the variables are restored. Execution
Not
continues where it left off before the
Alright,
recursive
so
call was made. But
now
because the
what we want to
recursive
do
call is the
is
last statement in the
we want
method,
to
there's
create
nothing
a
more
config
to
for the
execute,
course, right?
and the method terminates
want to
without
do
using
add
the
on
restored
click listener or
local
something like that,
variables
right?
values. In such
So
a
pretty much
case,
we need
the
to know that
recursion can easily be replaced with
Set
iteration.
on item selected listener. See that? Instead, right? And technically we can do pretty much just the lambda thing like that, correct? That we were talking about. Right. Sorry.
Let's
I
just
need
try
to
to
take
show
this
you
off.
but how to change
So,
from
your
recursive to
video is ready,
iterative. Now, what I want to
So first,
Alright.
look
So come
at
back.
is
So now we pretty much just need to
the overhead, right?
implement like what
So
you want
the
to do.
overhead-
we can do the toast the same, make text, right?
It's the time.
Right? What do
It's
you want to
called
make?
involves processing toolkit and dispose of the activation record and the
Get
manage
the application context.
runtime stack, right? Time to
And
manage. And the
Let's
space
say we
activation
we want to
records
say,
must be
do
stored.
you want to build a snowman? Right?
Another problem is that a particular recursive solution might just
And
be
then we
inherently
just go to
inefficient.
toast dot
This can occur if the
length
recursive
short.
approach repeatedly
Right.
solves
And
the
then whole
same
thing we
subproblem
want to
over and
make
over
it
again.
show.
have the values.
So they talk about clarity here, like why we want to use recursive.
One byte has 8 bits.
Recursive
8 bit can represent.
solution is simpler and more natural for the programmer
Alright, so
to
let me
write.
try to show you here, right?
So
Lambda
The word
expression are
provided by the
supported
system
at
stack
language
is
level
hidden,
1.7
and therefore a solution may be easier to understand.
because this is at 1.7, it's not used JDK 1.8. Like lambda.
So
starts
example,
in 1.8.
If I want you to write
So
so
that's why it's replacing with what
minus
the anonymous inner class.
recursive and non-recursive
Right.
approaches to print a
Now
linked
there are two
list in
ways. You
reverse
can
order,
upgrade
how
this
would
to
you do that?
1.8 too.
2.
So how would you do print the list in reverse order with
Okay.
iterations?
We can try, but let me show you.
So
with
you know
anonymous
that
inner
we have to
class
start from
first,
the
and then
tail.
come back to try to see if we can upgrade to 1.8. Okay.
760.
How do you
So short.
get to the previous.
All right.
Because
so
limited list,
first,
this is talk about
what
one
is
direction
anonymous
limited
inner
list.
class? Let's review one more time. I showed you earlier.
That's gonna be an issue, right?
So it's
With the
technically
iterative,
pretty
right?
much just replace this whole lambda
Correct.
context. You see that? With this.
How we going to do
New,
loops
right?
and make it
so we
reverse.
gotta type new. This is called anonymous
But
inner class.
this problem can be
view
resolved
dot
very easy with
right?
recursive.
View dot.
Now in integers, you can do
Because you can look at a smaller version of itself, meaning the first list
Now-
you pass in.
For the button itself,
To
we
the
call
method,
on
right?
click listener, right?
8.
But
And then
this is
you
depend
call
on the
itself
handler
again,
type.
pass
object
the
type.
smaller version of itself.
Okay.
That means
Like
you
let's
take the head
switch
out,
back to
2 minus
right?
this
Head is your
again.
best case, right?
1000.
So
And then you
This
keep
is
passing
pretty
until
much
you
the same
get to the
principal
end, which is
concept
tail.
with the basic
And then you just
Java
do print the
event
content.
handler in JavaFX. But I just
That's
want
it.
to
It's
try to
gonna print
use this
reverse for you
as
after that.
explanation a little bit on
That
this
makes
table
sense?
because we have this table.
See,
the
like this
button,
is just try to say
event
sometimes
object
we have to
has
use
to be action
recursive.
event.
Even we know that
See,
it is inefficient
combo
and
action event, but
overhead is higher.
3.
Okay,
maybe
that's
it's
pretty much
something
the
else. It's
example
gonna be
that I want you
mouse
to look
event
at
like scene
for application of
key
recursive.
event.
Then
Right.
you can pretty much just
So we pretty much just
Alright.
need to know that.
So
2 billion.
Hey, if I want
Now-
to use a spinner, right?
I'm going to
Spinner, what type of event, right?
look at
So
another
last time we were using
slide.
spinner.
So we talk about recursions. So what
So we gotta check what
else
type
are
of
we
event,
looking at?
right?
Now, let me see, when I declare that type, I keep the type.
in your test recursion, you probably going to have to identify best case,
this is a
and you also have to
And assign
spinner
read
right there.
to a starting value now.
be able to read the code and tell what should be the
They
output.
use adapter view, not the view itself, right? Like the button use view on click listener, but this is adapter view because pretty much there are many items, right? Like adapter, and then we call on item
So,
selected listener
Q.
instead.
After you declare,
Okay,
if you want to do that,
so that's what we want. So we gotta switch back. We're not gonna use
All right,
view,
so
but we use adapter
what I'm
view,
gonna do,
right?
I'm gonna have to stop
And
the
on
record
item
first.
selected
Okay.
listener. By selecting